So, we start with example number 1. We are given that x of n is equal to a power u of n, where a is a real number between 0 and 1. It is a positive real number less than 1. So, which means it is a convergent series. So, we can write down x e of j omega. Now, by now you are quite familiar with this expression. It will be 1 minus a e power minus j omega. Okay. Now, what the reason we are going to do this is we want to get the real part of x r e of j omega. In some of the properties we said that there is a certain characteristic of the real part and a certain characteristic of the imaginary part. So, we would like to obtain the real and imaginary part of x e of j omega. Now, what is the best way to do that? Best way is to, this is a complex quantity. So, multiply and divide by the complex conjugate. So, what is the complex conjugate of 1 minus a e of j omega, and numerator also you write the same thing. Okay, so, then you simplify. What you get in the numerator, 1 minus a cosine omega minus j times a sine omega. Okay. And denominator, it is a product of two terms which are complex conjugates. You will get 1 minus 2a cosine omega e power 1 minus 2a cosine omega plus a square. Okay. So, now it is easy for us to see what are the real and imaginary parts. So, by inspection you can write down x r e of j omega, denominator is fully real, 1 minus 2a cosine omega plus a squared, numerator is 1 minus a cosine omega. Now, for example, if you want to test whether the real part is an even function or not, you can easily substitute here and verify that it is a, so for example, if you substitute omega with minus omega, you will find that this is an even function. Similarly, we can also write down the imaginary part e power j omega, which is given by minus a sine omega divided by 1 minus 2a cosine omega plus a square. You can verify properties like whether it is even, all of that, and what does it map to in terms of the inverse discrete time Fourier transform. So, this is one type of calculation which is helpful for you to have. This is also useful when we are working with the Z transforms. Now, there is a second question that I would like you to think about, and here it is, example 2. This is a type of question in which we can have a number of sub questions. So, we are given the following, that there is an input x of n which is a finite length sequence 2, 2, 3, 3, 4. Okay, the origin is at the first 2. Second part, we are also given y of n. Y of n is 2, 4, 9, 10, 13, 10, 8, and the origin is given as 4. We are asked to find the impulse response of the LTI system which gives this input output relationship. Find h of n of the LTI system. Okay. Now, you can of course start writing down the the input output relationship. So, what is y naught, what is y1, y2 and so on. But just look at the input and the output and answer the following question. Okay, the first question, is h of n causal? what would your answer be? Okay. Now, remember, go back and look at, think about our sequences. If the impulse response was causal, the LTI system is causal, that means when there is no input, there cannot be an output. Okay. Now, notice that the output starts at n equal to -1, whereas the input starts at n equal to 0. So, definitely we can say that this is not a causal system. Okay. Second question, is h of n finite length? Finite length. The answer is yes, because the output is finite length, input is finite length, output is finite length, this is finite length. Third question, which probably requires a little bit more thought, is what is the length of h of n? What is the length of h of n? Okay, we know the following, that it is non-causal, it is finite length, and that it produces the given input-output relationship. We should be able to calculate. Now, of course, you can write down a number of equations and then solve and get the expressions. However, I will give you a very simple method to do this calculation. Okay, we know that the input-output relationship for an LTI system, y e of j omega is equal to h e of j omega times x e of j omega. Okay, so write down for me the expression for x e of j omega. X e of j omega is given by 2 plus 2 e power minus j omega plus 3 e power minus j 2 omega plus 3 e power minus j 3 omega. And then the last term 4 e power minus j 4 omega, e power minus j 4 omega. Similarly, you can write down y e of j omega, because you have a non-causal term. This can be written as 2 e power j omega, that is the first term, plus 4 plus 9 e power minus j omega plus 10 e power minus j 2 omega plus 13 e power minus j 3 omega plus 10 e power minus j 4 omega plus 8 e power minus j omega j 5 omega. Okay. Now, right by examining this, you will be able to tell me what is the length of the filter h of n. How can you say that? What is the highest power of y? E power minus j 5 omega. What is the highest power of x? So, when you multiply x e of j omega with x e of j omega, you will have powers of negative powers of e power j omega. The highest power that can be present is e power minus j omega, because if you had e power minus j 2 omega, you will have a e power minus j 6 omega in the output. So, you can easily guess that the expression for h is going to have only up to e power minus j omega. It starts with e of j omega because it is non-causal, and it will have something for the constant term, and again we should let us verify if this is indeed the case. So, for this I would like you to do the following long division. Okay, I am sure you are familiar with algebraic long division. 2 plus 2 e power minus j 2 omega, maybe I will just copy it from the previous page. Okay, this I will delete. So, this is my divisor, this is my dividend, I have to divide this. Okay, so this is my division process. Okay, you can do the long division and you will you can easily verify that what you get as the quotient is e power j omega plus 1 plus 2 times e power minus j 2 omega. So, which means h e of j omega is given by this expression. Okay, this is the expression for h e of j omega, which means the corresponding sequence h of n is equal to 1 comma 1 comma 2, where the origin happens in the middle. Okay. So, by looking at the DTFT you can get a lot of information, and also sometimes just by simple division you can get the input. The same calculation, if you had to do it in time domain, would actually require you many steps. You can try that. You will find that it actually is quite cumbersome, and this is what we have done is a very simple way of doing the calculation. Okay, and another type of question that you should be comfortable with is the following. Okay, so this is example 3. Okay, we are given that x of n has got a discrete time Fourier transform given by x e of j omega. Okay, now we are asked to obtain the DTFT of the following signal, in terms of x e of j omega, Okay, so the first of these sequences is x1 of n is equal to x of 1 minus n plus x of minus 1 minus n. Okay, so x1 is related to x. We are asked to obtain x1 e of j omega in terms of, you have to get the answer in terms of x e of j omega. Okay, we will give you just a couple of quick questions, some hints, and then you can use that to derive. Okay, so let us do the following. In the first step, we recognize that we have to shift by 1. Okay, so we will define an intermediate sequence y1 of n is equal to x of n plus 1. Okay, and a second sequence y2 of n is equal to x of n minus 1. One is a shift forward, other one is a delay. Okay, and we now can get x1 of n as, okay, before we do that, what is y1 e of j omega? y1 e of j omega will be e of j omega x e of j omega, correct? Similarly, y2 e of j omega will be e power minus j omega x e of j omega. I hope you are comfortable with that. These are the two expressions. Okay. Now, x1 of n can be written as y1 of minus n plus y2 of minus n. Please make sure you can verify comfortable with that result. And we know from the symmetry properties that if x of n has got a DTFT which is given by x e of j omega, then x of minus n has got a DTFT given by x e of minus j omega. Okay. So, y1 of minus n, I need to get. So, I need to take y1 e of j omega and replace omega with minus omega. So, I can write down x1 e of j omega as y1 e of j omega will be y1 e of j omega with omega replaced with minus omega plus y2 e of j omega, omega replaced with minus omega. Okay, one more step and then we get the answer. This will be this is where you have to be careful. E power minus j omega, wherever there is omega in the expression for y1 e of j omega, you must replace it. So, e power minus j omega x e power minus j omega. Okay, second term will be e power j omega x e power minus j omega. Okay, so we now can combine these two terms, take x e of j omega, e of minus j omega common, you will get e power minus j omega plus e power j omega. This can be written as x e of minus j omega times 2 times cosine of omega. So, x1 e of j omega in terms of x e of j omega can be written in this form. So, this is what this type of question is asking you to do. When they say write the expression for the DTFT of x1 in terms of x, then this is the type of calculations you should be comfortable and familiar in doing. Okay, let me just give you a minute. What did we do? We know that it's a combination of two sequences. We obtained the DTFT of both those sequences, and then the time reversal we saw that it can be obtained by replacing omega with minus omega. Okay, another interesting example. This is an application of the property of differentiation. Okay, so this is a second question that we must do. We are asked to give the expression for x2 of n, the DTFT of x2 of n, which is equal to n minus 1 the whole squared x of n. You want to get the expression DTFT of x2 in relation to x1. Okay. So, the first thing that we do is to expand this the square term, n squared minus 2n minus 1 times x of n, okay, and plus 1. Okay. Now, we know the following results. X of n has got a DTFT which is x e of j omega. N times x of n is given by j times d by d omega of x e of j omega, and n squared times x of n, which we derived just at the start of the class, if you remember, we derived n squared x of n is minus d squared by d omega squared. Okay, so write down that relationship, minus d squared by d omega squared of x e of j omega. Okay, so x2 e of j omega can be written as minus d squared by d omega squared of x e of j omega. Then the second term is minus 2j d by d omega of x e of j omega, and then the final term will be just x e of j omega. Okay, so we have expressed the DTFT of x2 in terms of the DTFT of x, but again because of the expressions that we have to take the first derivative and the second derivative, and this is helpful for us in getting the final expression. Okay, last of the questions in this type. Okay, x3 of n is equal to e power j pi by 2 n x of n plus 2. Okay, so it's a delayed sequence. So let us do an intermediate variable y1 of n is equal to x of n plus 2, shifted version. Okay. So, we can say that y1 e of j omega will be equal to e power j 2 omega x e of j omega. Okay, comfortable with that? The reason we are going to do this is because x3 of n is equal to e power j pi by 2 n times y1 of n. Now, this is a frequency shift. So, this is given as a frequency shift e power j omega naught n. So, it is a shift to the right by pi by 2. So, this will be equal to DTFT y1 e power j omega minus pi by 2. This is going to be the expression. Okay. Now, wherever there is omega, you have to replace omega with omega minus pi by 2. So, therefore, this will be equal to e power j 2 times omega minus pi by 2, okay, x e power j omega minus pi by 2. Okay. So, this is the final expression. Of course, you can simplify, you can write this as e power j 2 omega multiplied by e power minus j pi, okay, that will be minus 1. Okay, you can write this as minus 1 x e power j omega minus pi by 2. Okay, so, you can write this as minus e power j 2 omega x e power j omega minus pi by 2. Okay. So, the ability to obtain the DTFT using a reference DTFT by shifting, frequency shifting, time reversal, all of these are important elements, and I would like you to be comfortable with that and also be able to derive that.